Good. Okay. So, remember what we did last time? We started talking about language modeling. With the language modeling, okay, with the language modeling, we are going to do the statistical language modeling. The second homework will be due at the end of this month. The second homework will be due at the end of this month, and let me just make sure if it is there. Let's just this. Okay, homework number 2. Yeah. Homework number 2. Yeah, November 30th. Okay. So it will be character engrams, and I need to put some finishing touches, and it will be ready. Okay, this is not 2030, this is 2020. You don't have 10 years. Okay. So the just a minute. Okay, so we said that we are going to do the language modeling, but we are going to do the statistical language modeling. What we mean by statistical language modeling, we are not going to model the whole language using the linguistic techniques of morphology plus the parse trees plus etc. We are going to say that we are going to keep simple statistics of the language, and with the simple statistics of the language, when we see a new sentence, we are going to say that the probability of this sentence having happening is such and such. So for that one, we are going to use n-grams. We are going to use n-grams, and for the n-grams, we will see that the things are not turning out to be very well for the straightforward interface, straightforward implementation. So we are going to do some assumptions using the chain rule and the Markov assumption, and then at the end we will see how we did in terms of achieving what we tried to achieve, and after that we are going to see some other not very right, not very correct stuff with our model, and we are going to use smoothing to smooth things out. Okay, so just to preview what we did last time. If I have a sentence like this, I notice 3 guys standing on the question mark, and I ask you a few questions, and you gave me very nice answers, and you gave me some very nice answers, and the answers were like standing on the sidewalk, standing on the wall, standing on the chair, and etc. So it was all grammatically correct and physically correct too. I mean, I could stand on the wall, I could stand on the sidewalk, but I cannot stand on the blue, for example. 3 guys standing on the red. You don't say that, right? Because you need a noun, like a physical object, and etc. So to be able to fill in these question marks, you need to know the grammar of the language. You need to know about the real world, right? Common sense real world, etc. But the statistical language modeling says that no, you don't need to know anything about that. All you need to have is very large corpora. Okay, look at the statistics of the corpora. If you have seen such a sentence before, many times, let's say hundreds of times, just go check the hundreds of times you see this sentence and find the corresponding word there. The most frequently replaced word with this question mark is the one that you like to choose, most likely one. Okay, so that's what we are going to do with the statistical language modeling. Okay, guessing the next word. Once you do that, it is going to be a very powerful technique for us to use in many natural language processing tasks. And we said that we are going to base all of our statistics based on, we are going to base all of our statistics on this new concept of n-grams. Okay, n-gram means, okay, let's start with the 2 grams. In this place, I notice is a 2 gram. Notice 3 is a 2 gram. 3 guys is a 2 gram. Guys standing is a 2 gram. You know what I mean? Okay, in our corpora, a word coming from another word after the another word is just a simple 2 gram. Okay. If somebody tells me that how many times I see this 2 gram, I notice in my corpora, okay, then that will be a good statistics for me. Okay, notice three guys, etc. Using this information, I will put them together and I will try to find the most probable word for this question mark. Oh, I think I have a few questions about homework. Are we going to use Java for homeworks? It is up to you. Java or Python or C, C++, doesn't matter for me. As long as you write it yourself. Don't take your code from anybody else, anywhere else. You may use any. Okay, your homework is due. I just check your Moodle page, okay? Just check your Moodle page. Let me get some tea. Sorry, I need to get some tea, sorry. To get the tea, I need my mask. Okay, I got the tea. See, my background works with my face mask. It doesn't recognize. How about this? Does this work? Still works. Huh? It looks like it works. So it works with face masks. It's smart. It is smart enough. Okay. So likely word, that's what you're gonna guess. Okay, so it is going to be this. Probability of you know what this means, right? I mean, probability of word 1 being I, word 2 being notice, word 3 being 3, ... and word K means sidewalk. Okay, if I can measure this probability, then I will replace with sidewalk. I will replace the sidewalk with any word I like, X, and I will say take this maximum of this probability argmax X. Whatever makes this probability maximum is the word that I am going to pick. But usually I don't write it this way. I just write it the short form. I would say what is the probability of I notice 3 guys, etc. Right? Sidewalk. I don't say W1, W2. Each W1, W2 is a random variable, and I don't write that. Okay, so that's what I'm going to do. That's going to be our statistical language modeling, and this is good for many applications. I'm not going to go into that, and for this I need to do some counting, and we talked about the counting last time. I'm not going to talk about that again, and we talked about this definition of lemma and word form last time. I'm not going to talk about them. We talked about this slide a lot. We said that people kept statistics of word counts, and they have corpora. One is very old one, a brown corpora from 1992. It is old but large, almost 600 million word forms. Google is a much larger one. Google says that I have scanned everything. I have scanned everything that is written in English. We talked about this, and we said that it is very large. Okay, so back to word prediction model. This is, I mean, given these words, what is the probability of next word can be calculated very easily using what? Using this. This is the same as saying P W1 to Wn minus 1 over P, sorry, just the opposite, just this is N, and this is P W1 to Wn minus 1. Which probability is higher? This one or this one? Numerator or denominator? This one is higher. Why? Why, Selman? Why is this higher? Well, it should be okay. Well then, okay. If I didn't show you this, okay. If I ask you the same question, which one is higher? You are saying that, I mean, if it is the probability, then yeah. But I'm not saying that I am going to divide this one with this one. Okay. Which one is higher? Upper part or the lower part? It is not the numerator, denominator anymore.
The upper part has n words, which is more than the n minus 1. So it should be
smaller probability, right? It is.
Yes.
I mean, we can do an experiment.